Hello, everyone. Welcome to the Adventurers Club of Los Angeles. If you all are watching online, thank you for being here with us. We have a full house tonight. Just so you guys know, we are open for business. We had a wonderful dinner, and now we're about to have a wonderful program. Tonight, I have with me Jess Phoenix. Jess, thank you for being here with us.
Thanks for having me, Rich. This is really, really fun. First live event post-pandemic.
Yeah, we're excited to be having live events again. So Jess, you are a volcanologist. Is that the proper pronunciation for that?
It is, and I do get asked a lot, oh, can you tell me about Mr. Spock? And I say, well, yes, I also love Star Trek, and I want all of you to live long and prosper. I mean, that's very important. But no, I do volcano work.
Okay, but you are thoroughly knowledgeable at Star Trek.
Star Trek.
Well, let's stick to volcanoes.
We
then.
can do that. We can talk Star Trek later.
Why don't you start us at the beginning? How did you get interested in volcanoes? What sparked that passion?
Sparked. So you're already going with the puns, I see.
I'll go all night long.
I lava them. Yeah. Okay. It only gets worse, okay? No, it was sort of an accident for me. I thought I was going to be an English professor when I entered college. For people may have noticed, I have tattoos that say, only through time is conquered. That's a T.S. Eliot quote. I'm still a T.S. Eliot aficionado. But in college, I had an issue picking what I was interested in. It was like, well, I also I love horses, and I love sports, and I love history, and I love art, and and I ended up with a history degree. But during that course of events, I took classes just to see, hey, that sounds interesting. Let's do it. And I had an intro geology course Wednesdays in the evenings, 6 to 10 p.m. And no breaks. Yeah, and it was just once a week, but the professor would turn his back to the students and the whole lecture group and just write on an overhead projector the entire time. So the most boring of possible introductions to geology, but it didn't matter. For me, it was like, oh my God, this explains why mountains are where they are. This is like why the oceans are where they are. How do volcanoes erupt? What makes earthquakes occur? And the answers to those big picture questions, I mean, I've been asking them since I was a kid, but then you forget to ask them as you get older. And that sort of curiosity about everything and the wonder about the world that gets squeezed out of you, if you're like a lot of people. And that kind of reignited it for me. And then a couple years later, I mean, I got out with a history degree. I made it out, used the degree for a few years. And then I said, well, I can either go to law school or I can go to grad school for geology, perhaps. Do I really want to sit in a law library for the next 3 years? Probably not. And I said, well, let's try this geology thing. So I applied to Cal State Los Angeles, got into their geology makeup program, which is when you're a master's student, but you still have to make up like whatever courses you didn't take because you didn't have a degree in that subject.
Right.
So I took like physics with the undergrads while I was doing graduate level geology. That was fun. And I was teaching there too. So I would have students that I was with in physics then come take a geology class I was teaching. I was like, hey, I'm still learning too, okay? But yeah, and then I applied for a research position with the USGS Hawaiian Volcano Observatory. And for some weird reason, they said yes. And that was my first quarter. We were on quarters then. First quarter of graduate school. And they said, sure, come on down. And that changed my entire life. Basically, the second I set foot on a volcano, I was like, done. This is it.
So it's interesting because volcanoes are probably one of the most dynamic fields of geology, right?
Yes,
I mean, how could you not be enamored by a volcano, seeing the Earth being formed?
Yeah, I don't have one of the more boring professions. I'll put it that way. And everybody wants to talk volcanoes because I think they captivate people from a really young age. Because even little kids can understand, like, ooh, Danger Mountain is exploding. I mean, fundamentally.
The floor is lava.
Yes, the floor is. I did get called about that show when it came out on NBC, The Floor is Lava. And they said, can we interview you? And I'm like, if you must. And they were like, what would happen if the floor was actually lava? And I said, oh, this is fun.
Well, you're here now. What would happen if the floor is actually lava?
All of the contestants would be dead.
How fast would we die? If that floor was lava, Because let's get some context. If that floor down there was lava and we were sitting right here.
If it was just like a roiling lava lake, the gases would do us in pretty quick. Like
Okay.
we're talking a matter of like less than a minute.
You do have a picture of you. I'm going to skip ahead to a picture of you in a gas mask.
Oh, there are several of those.
Yeah, respirator, right?
Yes, respirator. That one, yep. And as you can see, that's there's a cloud behind me that's a bit yellowish. That's sulfur, but it's not just sulfur. It's sulfur dioxide, hydrogen fluoride, hydrogen sulfide. If you don't know, if you're not a chemistry person, those are acid gases, and they're not fun. Do not breathe acid gases. It will basically mess up your lungs severely in a pretty quick amount of time.
So you can filter that out with a respirator. You don't actually need like supplied air like you don't need
Not
like a
often.
SCBA or something like that.
There would be a time, like if you had to get really close, you probably would need it. In fact, in that picture, a lot of folks were, the film crew that I was filming with on that shoot for Science Channel, they had full face masks because the acid gases really do irritate your eyes as well.
Mm-hmm.
But the things I do when I'm on camera so that people can still relate to what I'm saying, if they can't see your eyes, I always get yelled at by film people, TV directors and such, because they say, take your sunglasses off, because I wear these big mirrored sunglasses. And I'm like, but my eyes, they are weak in the sun, it is strong. But they say you look like an android. And I'm like, yeah, you're right. So when I do stuff on camera, I try to keep my eyes uncovered, even if it stings, because those gases do sting quite a bit.
So this is for the picture.
That one, yeah, that one I just went, yeah, okay, I'll take the photo. But in that case, the gases were blowing over towards where we were, and because you can't always predict the wind, it was shifting. The plume of gas was just moving, and so we'd be standing there doing something, and then suddenly we'd be enveloped by it, and you could barely see anything, and it would be very stingy and not pleasant. So you always had to keep your respirator around your neck. I mean, that's what we do when we work on volcanoes. Is just if we're not using it, it hangs right here, so you can just put it on in a hurry.
Right, that makes sense.
Yeah.
So one of the first places you got to work or volunteer, you were a grad student at the time, was the Hawaiian Volcano Observatory.
Yes.
So can you tell us a little bit about, I mean, everybody knows Hawaii is a volcano island, right? But give us some sense of what's going on out there.
Mini lecture.
Yeah.
On the map, you can sort of see Hawaii. If you're far away, you may not be able to make it out, but hopefully you have an idea. It's an island chain. The islands that are to the east, the big island of Hawaii is the largest, and it's the furthest east. And then it goes, basically Maui, and then the smaller islands, and then Oahu, and then Kauai, and then the others, which are basically being eroded back into the ocean because they're no longer volcanically active, so the ocean is reclaiming them. With the Big Island, however, you do have volcanoes that are currently erupting. Kilauea and Loihi, which is the undersea volcano that will be the next Hawaiian island in a really long time. So don't buy real estate unless you plan on living like more than 10,000 years. Okay. So not a good investment property. You heard it here first. But Hawaii itself, the island, is made up of 5 volcanoes, and 51% of the island is made up of the really amazing volcano. My favorite one on planet Earth, because it was my first, Mauna Loa, and that name in Hawaiian means the long mountain. And some of you may be familiar with Mauna Kea. That means white mountain because it does get snow. Because both of those volcanoes, they get snow because they're almost 14,000 feet above sea level. And Mauna Loa, when you measure it from the base on the very bottom of the seafloor to the summit, is larger than Mount Everest. So it is the world's largest volcano. And there's other volcanoes there. Kilauea is like the little baby one that's next door. The summit's only 4,000 feet high, but it's super active. And it was the world's most active volcano for basically from the 80s up until 2018. And then it kind of had a bit of a pause for a few years, and then it started erupting again in December 2020. So I got to work on it at the beginning of the summit eruption that started in 2008. And it's amazing because there's a lava lake at the summit. There was lava erupting from a cinder cone on the flank of Kilauea called Pu'uo'o, and there was lava flowing into the ocean. So you had really incredible views, whether you were in the heart of the island or kind of towards the barren wastelands that are just all lava, or if you were right on the ocean in a boat, you could actually see what we call laze, which is when lava makes contact with water and it produces this haze, but it's actually also acidic, because volcanoes love to be acidic.
So it's not just steam.
Yeah, it's not just steam,
Yeah.
and it's also hazardous to breathe in. So basically everything with volcanoes is hazardous, or really, really fertile and good for growing crops or wine or what have you. So people love to live near active volcanoes, which is why we study them, because we want to save lives. I mean, ultimately, that's the goal.
Yeah, so we always hear about how, you mentioned, the most of the Hawaiian Islands are inactive volcanoes. And you say, this one's an active one. And we hear, okay, so on a geologic time frame, like this is nothing. It's a blink of an eye, right? So give us a sense, like, in Kilauea, it's active right now, and it's erupting over and over, but people are living on that island.
Oh, yes.
What's the real danger? Like, how does that work? What are you guys trying to do to mitigate that?
I mean, if you paid attention to the news a few years back, lava flows are a really big hazard there. And lava flows are not really a hazard to human lives so much, because even the runniest of lavas, like what you see in Hawaii.
We had some pictures of those, right?
Oh yeah. The oozy, runny basalts, there's a really up close one of what we call a toe of pahoehoe lava. That is a Hawaiian word. It's the ropey, oozy, runny type of lava. And that's a basalt, if you know your rocks at all, if you ever took intro geo. Basalt rocks have a lot of iron and magnesium in them. And so they are weakly magnetic if you get a ton of stuff in them. If you get a lot of it, I mean, it's got to be a lot, but they have a low silica content, so they're less likely to do explosive eruptions. Like, you're not going to see Mount St. Helens in Hawaii. That's a different type of volcano, much stickier lava, so you get more explosive events. But like in Hawaii, the big hazard though is lava flows, because you can move yourselves. Like, even people who have, a hard time moving around can get away from most lava flows, because they'll top out on average at about 6 miles an hour. So a brisk walk and you're going faster than it. But, and the fastest they usually could ever move is 18 miles per hour. So it's houses, it's property, it's things that you can't easily move. So that's what the big goal of doing volcano hazard assessments is on the Big Island. It's basically to say, all right, like, who's in danger, who's in harm's way, what are the hazard zones, and how do we prepare to evacuate people, and what advice can we give people who want to live here, who want to build here? So it's a constant thing there, but it's a lot less immediately dangerous to people than other volcanoes around the world. If you've been paying attention to the news about Iceland, with that eruption that's going on there at Fagradalsfjall, that is a really awesome eruption to watch, because so far it's nowhere near anywhere populated. So people can go up and see it. It's oozy, it's runny, and it's not likely to hurt people.
So if it's oozy and runny, it's fairly safe because it's moving, right? The dangerous ones we're worried about are Mount St. Helens, where it kind of bulges and bulges and the pressure's building, right?
Yep, and like Mount Etna is a big one on Sicily in Italy. That is a very dangerous volcano. Currently in the US, I have my eye all the time on Mount Rainier up near Seattle and Tacoma. Rainier is uniquely dangerous because not only does it have the stickier, more silica-rich lavas, it also has over 30 glaciers on the top of it. And what happens when hot stuff meets cold stuff? You get melt. So, that's pretty logical. And the biggest threat from Mount Rainier is actually what we call lahars, and those are volcanic mud flows. And they can be cold, they can be hot, but they actually will move at, not blistering speeds. We're talking maybe like 40 miles an hour, more or less. But those will barrel down, riverbeds, stream channels, any depressions in the landscape. And they can, for an example of what they can do, most of South Seattle and Tacoma is built on about 100-foot thick mud flows from Mount Rainier that are ancient. So,
wow.
Yeah. So I would not live there. Just saying. If you have any friends there, tell them I'm sorry.
And okay, so when you find out about these events, like what's your goal in terms of like giving someone a heads up? Like, for instance, Pompeii, right? if there were modern scientists sitting around Pompeii,
there are.
Well, if there
you mean
were
back then? Okay, yes.
Back in the disaster, what kind of time frame could you give people to be like, hey, time to get out of here?
Well, that is the tricky thing. We cannot predict eruptions. That's just not something that we have the capability to do. So if you ever see anybody online like, oh yeah, Yellowstone predicted to erupt, It's a bogus article. Do not believe it. It is crap. But what we can do is help to say, okay, we're assessing everything the volcano's doing. We're basically keeping tabs on it like a doctor would for a human patient in the hospital. So instead of checking like your pulse and your respiration rate and your blood oxygen levels, we're saying, okay, what is the frequency and the size of earthquakes? How much gas is the volcano releasing? And what is the gas made of? What is the lava that it's producing like? Or is there lava? Is the ground either inflating or deflating as magma fills in the chamber beneath ground, or is magma draining away? And those are the kind of things that we do to keep tabs on a volcano's activity. And even so, the modern era of volcanology started with the eruption of St. Helens in 1980. That's kind of what kick-started investment all around the world into different volcano monitoring methods. And during that eruption, scientists said, leave. They were like, the whole USGS is there going, please keep the area evacuated. We don't know when something is going to happen, but it's very likely that it will. And that's the problem, is humans want certainty. I mean, we all want that. And science is all about uncertainty. We try to eliminate uncertainty to get at the truth, but it's hard.
Yeah.
And as humans, we're like, we want to be able to tell you, oh yeah, next Tuesday at 9, it's gonna blow. We cannot do that. So we have to be able to, as scientists, live with that uncertainty and then figure out how to put it in terms that regular folks can understand and to weigh the risk. So that's that's fundamentally what drives what I do and what the scientists at volcano observatories all around the world do.
So why don't we tell us about some of the tools that you guys, you mentioned some of the things, you kind of skimmed over them, but like when you do check the respiration of a volcano,
yeah,
or you're monitoring gases, are all these separate disciplines that different scientists are working?
So yes, you do get specialization. So there are volcano seismologists, and they do earthquakes in relation to volcanoes, which volcanic earthquakes are different than ones that like the San Andreas would produce, because it's magma moving around underground and breaking older, colder rock. So you get these little localized quakes. Those folks study that, and they can tell you, oh, we've had a cluster over here, and they've been increasing in magnitude or frequency. You also have gas geochemists that analyze the gases, and you get people who do deformation studies, and they'll do the geophysics of the volcano. They'll use satellites and INSAR, which is one of the satellite techniques, to see if the ground moves up or down on the order of millimeters to centimeters. So this is some pretty intense instrumentation, and actually some of it was developed in the military. Like we have used these things called tilt meters, and you can install a tilt meter, a couple, like generally about 2 miles from a volcano, and you can tell if the ground moves a millimeter up or down.
Huh.
And that was, I think, developed by the Navy, actually.
Interesting.
Talking about your Navy background earlier. Yeah. But yeah, a lot of tools that are developed for another field often make their way into geology and volcanology. I mean, like I think there's a photo in there of me sampling some lava, and this is my favorite tool of all. So if we pull that one up, okay, so.
Is this it?
Yeah, it is. And actually there's 2 photos, there's a sequence. One is, I think that's the first one. And what I'm doing there is using a hammer. Just not in the way that you would to hang pictures. It's a different kind of hammer. It's called a rock hammer. And rock hammers are a single piece of drop forged steel. So it's not a separate handle and head. It's literally just all one thing with a rubberized handle. And that means it will withstand being stuck into 2,000-degree lava. And we retrieve samples that way so that we can, basically we hyperquench them. So we drop our little bleb, that is a technical term, a lava bleb. You get it on the end of the hammer. It's the taffy from hell. That is how I've described it, and I will always describe it that way. And you're so close to this radiant heat that you can literally feel your eyes dehydrating. I mean, it is surreal, because if you are familiar with baking and you have an oven at home, it'll go to about 500 degrees Fahrenheit. And this stuff is, 4 times that. So it really does. You can't blink after a certain point. And you have to actually use your heat-resistant gloves to shield your face, just to get in close enough, see where you're going to stick the hammer in, and just put it in and then pull back and hope you got it. And then once you get it, then you drop it in just a regular coffee can or metal bucket of any sort, just full of room temperature water. And that lava bleb goes from 2,000 degrees to a hell of a lot cooler in a second or two. It's what we call hyperquenched. And that preserves the gases and the minerals inside the lava. So we take it back to the lab and we put it on a mass spectrometer and we basically analyze the components. And that shows us like, okay, this is what's going on underground. So it's like getting like a blood sample or something from a human. And we use that to say, oh, look, there's a lot of crystals. That means it's cooling slowly in there. Or there's almost no crystals. I guess we may have something a little bit runnier on our hands. So it's that sort of, I mean, obviously that's super fundamental, but it's that sort of analysis and getting boots on the ground data. I mean, that's what I love. That's why I do this. And you wanted to talk about other sampling tools. There's another cool one that I think I included a picture of. It's me with a yellow area in the background, and I've got what looks like a flexible tube. Yes, that one. So that is, I'm sampling gas there. And I've got I'm really using a bicycle pump. Again, super high tech, right? But I've got a bicycle pump, and what you can't see, because I'm blocking it in that photo with my knee, is a glass bottle that is an evacuated glass bottle. So it has one gas in it only. And then as I suck the gas out with the bike pump, it goes through the flexible tube and it goes into this bottle, and I can take the gas back to the lab and analyze it. And what I'm getting the gas from in that photo, that was what we call a fumarole. And you may have heard that term if you've been around any volcanoes. Fumaroles are little cracks in the ground where gases can escape. And gases like to expand and rise, and hot stuff rises. So hot gas expands and rises. So that's one of the ways that we do keep tabs on what's going on underground without actually being able to see underground.
So you mentioned, lava, and I kind of want to back up for some basics, right?
Sure.
So I can walk outside and I see a lot of different types of rocks.
Yes.
I kind of assume that those all started off as molten at some point and then they solidified. But when you say lava, how do we distinguish lava? What is lava in terms of actual rock?
That's a very good question, because I would actually love if every TV executive ever could understand that. So magma is underground, and lava is what is erupted onto the surface.
Okay.
And lavas can range. Basalts are going to be the most iron and magnesium rich, all the way to, you get andesites, rhyolites, dacites. These are much lighter rocks, and they're less dense, and they just have different mineralogy. And so they do different things when they erupt. And like these, sometimes there are areas of the world where you have what we call silicic large igneous provinces, where you get all of one of these stickier types of lava that have somehow managed to erupt over hundreds of miles. So that, like the Sierra Madre Occidental in Mexico, I've done a lot of research down there, and it's these massive areas where I'm like, this should be basalt, but it's not. It's a different chemistry. And that sort of stuff, it really is. We have some answers, but geology is a relatively young science. So there's still a lot that we need to know in order to keep people safe, especially because, and I love this statistic because it really kind of drives it home, because we're like, oh, we live in LA, like there aren't volcanoes here. Actually, Amboy Crater is not too far from here. And we have geothermal energy that we tap into in Southern California. And then we've got Lassen and Shasta up in NorCal. So we have volcanoes here, and some of them are just on the other end of the state. But 500 million people around the world live in the shadow of active volcanoes.
Huh.
Yeah. So, I mean, that's a lot of people.
500 million people.
Yeah. So it is a lot. And when you think, how many billions are there? 7 something now? That's a lot of people. And that means that, it's not just in places where the countries are wealthy. I mean, these are in some of the more impoverished countries around the world. And I'm happy to say that St. Helens really was a wake-up call. I mean, even though 57 people died, it caused a lot of countries to actually make investments into volcano monitoring. And they started to say, you know what, we do need volcanologists.
Yeah.
Because otherwise, how are we going to tell people, hey, this thing is probably going to do something?
Well, it's interesting what you said about the uncertainty, right? Because, I was very, very young, maybe not. When did Mount St. Helens go?
1980.
Okay, so I was not alive at that point.
I was not even an embryo.
But from what I heard is they saw a bulge on the side.
Oh yeah, it's 500
But I mean, you still
feet.
have, you still have, you look at the mountain, you're like, oh, that's a different shape.
Yeah.
But I mean, there's still uncertainty, so.
Well, we didn't know. I mean, I say we, meaning the volcanology community. Literally, I was not alive. I was born in '82. math people now know how old I am, but basically they said, okay, it's bulging out the side. Why? They didn't actually know, and because at that point we didn't have a documentation of a volcano erupting laterally, sideways. And that's what St. Helens did. There was an earthquake, which triggered a landslide, which basically uncorked the volcano and sent that
everybody knows
blast.
the pictures. It comes out the top, right?
Yeah, and I mean it did, after it started to go.
Right.
But I mean, pressure wants to come out wherever it can, and in that case, the weak spot happened to be on the flank of the volcano. So that really, that revolutionized the way we think about how volcanoes can erupt explosively.
That is a tough thing to think about from the uncertainty standpoint, because again, what's the time frame? I asked earlier, like, say, hey, something's going on, 500-foot bulge, probably not good, probably shouldn't be around this area.
But for how long?
could be this week, could be next week, could be a year.
Yeah, or it could just quiet down, and that's that.
And then if you're the scientist saying, hey, you got to watch out, and then nothing happens, everybody's like, another.
They want certainty, and you will never get that with volcanoes. And the only thing we can say is the certainty that, hey, this volcano is going to erupt again in the future, like Yellowstone. That's the #1 question I get asked is, what about Yellowstone? And I'm like, don't read the clickbait articles on the internet. Yellowstone, okay, you're more likely to win the Powerball in our lifetimes than you are to see a devastating, catastrophic eruption of Yellowstone. So you can sleep easy about that one. If we do see a Yellowstone eruption in our lifetimes, anyone in this room, it's probably just going to be a small, localized, steam-driven or phreatic event. Like basically geyser on steroids. And it'll be bad if you're there when that happens, but they monitor it very well. And we can tell you, oh, things are changing. Change doesn't always mean bad. It just means different. And so we have to keep an eye on it. And they do have an observatory that's focused just on Yellowstone. And one of the guys I worked with in Hawaii actually is the head of that observatory now. And so they have good people on it, but don't worry about Yellowstone. Like, really don't.
So when you're on a volcano, how much do you worry about what's going on? Because to a certain extent, it's there. You're going up and you're coming down, and I understand that there's it's probably not going to happen when you're up there, right? But there is stuff that's happening, and it is active. What's that like, being on the side of a volcano with?
Well, do we have the picture where it's me and a couple guys, and there's a volcano erupting in the background?
That's a perfect picture.
That's the really good picture, because, yeah, that one. So I was filming a show for Discovery, which was actually terrible. If you really want bad TV, it's called Trailblazers. It's on Amazon. I apologize in advance. They told us the show was going to be entirely different than it was, and I know you watched some of it. But the wonder on the camera guy's face in that photo is genuine.
Yeah.
Oh, and the interesting thing about that is that we're there, we're in Ecuador. We're at a volcano called El Reventador, which means the eruptor in Spanish. And true to its name, it was erupting every 30 minutes. So we're talking like, we're trying to get something done, and oh, look, it's erupting again. But, the other volcanologist, well, he's a volcano geophysicist. He works at Boise State. His name's Jeff Johnson. Jeff and I were like, oh yeah, it's erupting, that's great. We were really excited the first 27 eruptions. And then we were like, okay, it's gonna happen again. Let's keep going. And the film people were always like, are we safe? and then I'm like, well, yes and no. Where we were in that picture, we were about 2 miles from the cone there, and where the eruptions were happening. And volcanoes will throw lava bombs out, which are just like what they sound. They're volcanic bombs made of lava that fly through the air at speeds of up to 190 miles an hour. And those can go about a mile from where they come out. So when we were up filming the latter parts of the show, we were real close to it. There were lava bombs. We were in lava bomb range. And every time we heard an eruption, we'd yell, rock, and then run and take shelter behind one of the big lava bombs, because they can be the size of a Volkswagen bus. And so we would hide behind them, and everyone goes like this, and then we count, because you can measure, how long it takes something to travel that distance. Yay, math. And then basically, once you'd counted that long, you go, okay, back to work. Let's keep filming. So we could, when we're up that close, like when I do sampling and stuff, not just for TV, but real work. Not that TV isn't real work, but we don't always get to do the best science. Sometimes they make us do like pseudoscience. Like we do it, but it's not as thoroughly as we would in real life. But we, when we do the real work, a lot of times we're in those hazard zones. And the day that St. Helens erupted, the eruption column was rising from the center of the volcano. And they sent a crew up there in a helicopter as close as possible. And they had one of the volcanologists lean on the skids of the helicopter with basically a strainer, like a pasta strainer. And he scooped up the volcanic ash that was coming out. And then they flew away.
Wow.
And yeah, but that's the sort of thing that we did when we were like, oh my God, how awful is this going to be? Now we have better monitoring. There's more funding and stuff. Still, we need more, right? Your Congress people, fund volcano research. But it's like, we had enough knowledge at that point to say, okay, we're going to get up, we're going to get this, but the helicopter, it could be, gone, and so could everyone in it. And that's something, there's acceptable risk, and you have to decide what your risk tolerance is. And for me, I will tell people, I'll say, that is dangerous, we're not doing it. But what I've learned is I've done a lot more TV since then. I will tell the film crews and the directors and producers, I will say, 100% when we are on this volcano, you listen to me. Like, I don't care what your budget is. I don't care what shots you need to get. If I tell you we're leaving, we're leaving. And I've gotten to the point where I'm really good at scaring them when I need to. And so we're a lot better now. Now I know how the industry works more. So when I do more public-facing stuff on camera, now I'm a little bit better about asserting. And it's a challenge because, a lot of the expedition shows are, Bear Grylls, like grizzled man, and then when they see me, they're like, pfft. And so now I'm like, oh, no, you're listening to me. And here's why, because I don't want anyone to die. This is a TV show.
I do miss, what's lacking in these TV shows, and you probably agree with this, is, just people doing real work out there. Every time I watch one of these shows, and Trailblazers included, if you guys watch this, the face that she's making now, she made on the side of this volcano quite a bit, actually.
They asked us to do some ridiculous things, and I was able to talk them out of some of the worst ones. But at the time, I was like, oh my God, I'm trying to get people to know about volcanoes and to be curious and excited. They never let scientists on TV doing real science.
But that's the truth. I watch these shows. I'm like, what are they doing? Why are they doing that? No, you would never do that. Don't do that. Stop.
Oh my God. Yeah, it's come a long way. I actually did a bunch of things for Science Channel, and I think there's a couple photos in there of those shoots. I got to go to Tanzania, and there's a black and white picture in there of me with a volcano in the background, I think. If that one's not there, then there's one of, I think there's one with any ones with me and camera crews. There's a few of those. But, in Tanzania, we actually asked the Maasai tribe elder for permission to go and work. And I said, we have to show this on camera because I refuse to be the, white savior scientist parachuting in and saying, oh, locals don't know anything. Like, no.
Right.
So now what we really try to do whenever I go to any of these locations where it's not my home, I try to involve local scientists, and I'm kind of insisting on that now. And the more experience you get, the more in demand you are, and the more you can dictate. So for the latest show I did with Discovery, I did give them another chance, and we went all over the Mediterranean. And the best part is we got to show a lot of the real local scientists doing the work, and we actually did the work with them. Because I said, I'm not going to just do bogus stuff on camera. Like, I need to be able to show the public that scientific work isn't just lab work. It's all, that's important too, don't get me wrong, but it's also boots on the ground, it's adventure, it's exploration, it's being creative and solving problems on the spur of the moment, maybe when people are in danger. And that's the stuff that places like the Adventurers Club or the Explorers Club, that's what we do. And the public thinks that all stopped with, Shackleton or with, Hillary and Norgay and the astronauts. They think that's it. They think we've explored everything.
Yeah.
And I'm like, are you kidding me? I'm putting an expedition together to go to the world's newest lava lake that we've confirmed just a couple years ago as a lava lake using satellites where nobody's ever been.
So what's a lava lake?
Oh my God. That was good. That was a good lead. I like that. He's good at interviewing.
I try.
You can keep him around. But no, lava lakes are amazing. And there's usually about 7 or 8 on Earth at any given time. And it is exactly what it sounds like. It is a roiling pit of hell. And they appear in a few different places. Like Kilauea in Hawaii has a lava lake currently. You may have seen footage of that when it started in December. It was pretty spectacular. And then you've also got some in Vanuatu. You've got a couple in Africa. Near Ragongo is one, Urdaale is another. And then you've got Masaya in Nicaragua. And then even on Mount Erebus in Antarctica. So they're all over, but there aren't that many. And they're really amazing windows into the guts of the planet. I mean, this is the beating heart of Earth itself. And we are lucky enough to be able to see it, to study it. And then it's not just academic. For me, like Lindsay at dinner was asking me, she said, well, why do you like volcanoes? Like, what was it about it? And I said, well, it's because the Earth is simultaneously giving birth to itself and destroying itself. I mean, it's the whole cycle in one. It'll create land and destroy land. And it is also, I mean, it's the fundamental state of our planet. It was all, roiling hellscape at one point. And it gives us insight into the origins of the universe and what will happen on this planet long after we are all gone. And we get this window into an active process that is so much bigger than any of us. And that's why I love it. So lava lakes to me are the coolest thing because we can see the center, the core of Earth in a way. Not the literal core, but like what makes it a dynamic planet and what makes it possible for us to live here.
But yeah, theoretically, so these are open to the sky, basically. You can look down in it.
Yeah.
That'd be pretty creepy.
Oh my God, it's amazing. And they sound, let me tell you what they sound like.
Yeah, I was going to ask, let me back up a little bit because I had a sound I wanted to ask. So you said you'd hear this thing erupt and here comes a lava bomb. So you hear, what did that sound like? And you knew that you had to go duck and cover because basically incoming?
Yeah, even when there's heavy cloud cover and usually, sound doesn't travel that well, you will know the volcano has erupted if you're within about a mile of the summit because you feel it in your chest. Volcanoes produce infrasound, which is, of course, sound that's below the range of human hearing.
Because the whole Earth moved.
Yeah, it's a big deal. And so volcanic infrasound is it's an emerging area of study, and it's been around for 10, 15 years now. But you can record infrasound using special arrays, and then you can bump it up into the level of human hearing, and it sounds like, I don't know if you all saw Lord of the Rings, but it sounds like if the Eye of Sauron was talking, it's like, and it sounds like what you think a volcano would sound like.
Yeah.
And so you can't hear that when you're on the volcano, but you feel it in your chest every single time. Every eruption, you're like, oh, there it goes. And then you may hear something. If there's cloud cover, you'll hear it'll be faint. But if there's no cloud cover, I mean, it sounds like an explosion. And if you were looking at it, you do hear the delay. So the sound doesn't reach you until after you see the image of the plume coming up, the eruption column starting. So it's cool because you can see physics at work, basically. You're like, oh, I saw this before the sound reached me. Because when they actually explode, they're moving pretty fast. That debris is coming out. And pyroclastic flows, which are made up of clouds of rock and gas and ash, those go down the sides of the volcano up to about 500 miles an hour. So we're talking
that's like an Earth avalanche, like if the Earth was moving like an avalanche moves.
Exactly. And that's actually what was pretty devastating in both Pompeii and also at St. Helens. So that's why you had the forest just kind of leveled for quite a ways out after the eruption. And in Pompeii, a lot of people were killed by the pyroclastic flows.
Huh.
Yeah.
So bring us forward to the sound of the lava lake.
It's the best. So I'm sure you all are familiar with Greek and Roman mythology. I mean, at least passingly familiar. And so you probably know that in Roman mythology, it was Vulcan was the god of fire and the forge. In Greek mythology, it was Hephaestus. I always want to say Hephaestus because I didn't know how to pronounce it when I was a kid, but I loved reading. So, sometimes my pronunciations haven't caught up.
That happens sometimes, huh?
Yeah, especially with those Greek names. Oh, my God.
Oh, yeah.
But Hephaestus, in Greek, and Vulcan in Roman. And they would say that the god was like the god of the forge. And, he was a metalsmith. He would make armor and weapons. And it's like what horseshoers do today. But that's actually what it sounds like. So those ancient Greeks and Romans, they thought, wow, the earth is making banging noises. What is that? It literally sounds like somebody hitting metal on metal when you're on the rim of a lava lake.
What is it?
It is the sound of rocks banging into each other and gas exploding. You can hear gas rushing, and it sounds like a jet engine, too. So you hear these jet engine whooshing noises, and then you hear bang, bang, clang, clang. I mean, it really sounds metallic, and it's incredible. And The first time I worked on the rim of Kilauea, when it had a lava lake there, we were installing an infrared camera right at the edge that was solar powered. And we walked out there, and the supervisor that I had that day, he's now at the Alaskan Volcano Observatory, but he comes out and he goes, okay, so we're going to set this camera up. We're going to do this and this. And he goes, if you hear a really loud bang, just drop what you're doing and run. And I'm like, okay. And then he goes, you do know there's a very real chance we could die. And I'm like, yeah. And he goes, okay, you know, hand me the pliers or the wrench or whatever it was. And I'm like, this is so cool. Because we're doing it for science.
So you said that wasn't in like the safety brief before? That was like after?
No, that was like while we're out there. I mean,
was everybody kind of messing around? He's like, these guys aren't taken seriously enough, just by the way.
He just was like, oh, I forgot to tell you because you're new. It was like, oops, because you know, they assume you have a basic understanding of geology. So, you know, you can identify rocks and minerals and you know basic principles. But, you know, you learn it on the job. There's really no other way to learn what you do in volcanology unless you go do it, because it's so varied. And, you know, I'm what they call a physical volcanologist. So I don't specialize in any of one of those things except for overall volcanic hazards and risks. Like, that's what I do. So if you wanted me to make a hazard map of a volcanic area, that's my bread and butter. And then I specialize in lava flow hazards and different types of lava flows, because I love the Hawaiian ones.
So it was interesting because in that TV show, you weren't the main safety officer.
No.
I feel like if I was hiking around a volcano, I'd be like, Jess, tell us where to walk. Can we stand here? Is this okay?
That's, yes. If you ever come on a volcano with me.
I'd be asking a volcanologist.
You should be.
Yeah.
Then, therefore, you are already, like, you have a leg up on most of the TV executives I've talked to. I have had people contact me because I kept a blog when I was working at the Hawaiian Volcano Observatory. And I mean, people find it because there's not a lot of volcanology blogs out there. At least there weren't in 2008. And I got this one company call me and say, okay, we have a daredevil. I'm like, oh, crap, here we go. He wants to ride a special bike, a motorbike, that NASA is going to make the wheels for. I'm like, oh, sure they are. And he wants to drive across the surface of the lava lake. And I'm like, I said, okay, you can't do that. You'll die. That's it. You'll die. Okay, well, maybe not a lava lake. What about a lava flow? Because, you know, those are a little cooler. It's not roiling. It's just oozing. And I'm like, physics, you can't do that. It's gonna sink. Like, it's not solid. It's a plastic solid. It's, you know, you've melted rock. It's not, no.
So is NASA working on this? Because it seems like,
no.
Is NASA working on tires to like, or whatever?
I think these people,
and then they just found a guy, they're like, oh, this guy will test it for us.
I know, he'll do it. I mean, we gave him whatever, you know, and that's what I was like, maybe these are the producers doing all the cocaine I heard about in Hollywood. Because, you know, I'm not from here, so when I moved here, it was an adjustment, especially doing science on TV. It's getting them to say, look, we can make really cool TV, but you need to listen to me to make it not laughable and to make it like educational in a way too. Because you want to thrill people, you want them to be like, wow, that was dangerous. But truth is stranger than fiction.
Yeah.
And I tell them all that now. I'm like, I will blow your mind on a volcano, and we don't have to make anything up. We don't have to script it. You know, we can get these beats for sure, but you don't have to try to add any drama. It's going to happen.
Well, one of the funniest scenes in the Trailblazer series, for those of you guys that might want to watch it,
is no.
They pull out a grappling gun that shoots a grappling hook. Is that something that you use a lot, just to dispel any?
For those who didn't see that, the answer is no. When we got there, we were, you know, Jeff and I, the other actual scientists and I were like, what's in that case? Because it was a big, long case, you know, big black case with these heavy-duty clips on it. We're like, what's in there? And we went over to the safety officer for the shoot, who was a former British Royal Marine Commando sniper. So he did actually, he did all the stunt rigging for the Avengers, the second Avengers movie, and all sorts of stuff. So this guy, I mean, he knows his stuff. And I was like, Aldo, what's that? And he goes, I can't tell you. And I'm like, why not? He goes, because you'll laugh me out of the volcano. And then when they brought it out, I was like, what do you want to do with that? Like, oh, well, the Trailblazer, who was an ex-Navy SEAL, really sweet guy, which is the only reason Jeff and I agreed to continue doing it, because we almost walked out. We were like, this is ridiculous. But Sean was a sweetheart and was a really cool guy. And they had Sean, they were like, Sean's gonna fire the grappling hook up this cliff, and then he's gonna use that to like climb up, and he's gonna free climb it, and then he's gonna set a belay rope, and you guys are gonna climb up the cliff. And I'm like, why? Because, spoiler, the cliff was actually the side of the volcano's caldera. It wasn't even going towards the cone in the center. We were like going completely the wrong way, but they just wanted us to climb this cliff for drama. And we were like, this is awful. And so Jeff actually, he and I have both gone and done way better science TV. He actually went, he was so motivated, he got one of the Nat Geo Explorer grants, and like now did a little film project about different volcanoes with some students, and it's way cool. So
yeah,
I don't know what the
like
name
you don't
of
have
it
to
is.
you don't have to, you know, French up a volcano, right?
No,
It's good
no.
enough, right? Or a lava lake. Just shoot the. But the show did get some amazing footage of that thing erupting, because I mean it's erupting every, what do you say,
30 minutes? Though they missed the best footage that they would have got.
Yeah.
We were right up close to it on the time when we were filming up just at like a mile from the summit. And we were completely soaked, because you're in Ecuador. You're 4 miles from the Amazon basin. So like it was just pouring constantly. And we were just soaked to the bone. I mean, every piece of clothing I had was wet. Even though I was wearing rain gear, it didn't matter. And so we were there like, okay, we got to take these socks off before we, you know, eat dinner out of our little bags and then set up camp. And, you know, I'm pulling my boots off and my socks. Camera guy says, I got to change the battery. Pulls the battery off of his camera. The volcano erupts right in front of us. And you can see hot, because it's dark, so you can see the incandescence of the rocks rolling down the volcano in this spiderweb pattern. And we were all just like, I mean, everybody, because it was
standing there with his battery.
Yeah, and Danny sat. That was the camera guy. He's Bear Grylls' main camera guy, but he's standing there with the battery in his hand. We're all just open mouthed, like we're kids seeing our first fireworks display, and we're just like, everybody for like a full minute until all the incandescence died down, and Danny just starts cussing like you've never heard. I mean, and he's British, so he's got some cuss words, but I've never heard a man so angry about missing a shot. And he doesn't let it go. Like, I've talked to him since, and he's like, I'm still upset about that.
That sucks.
I was like, I know, that was like the best thing I've ever seen in my life. So, and I was like, well, sorry, Danny, guess you're just gonna have to go work on a volcano again.
Oh, there you go.
Yeah.
I'm surprised. I mean, of all these volcanoes, we have cameras pointing at them all the time, right?
Not all of them.
Not all of them?
Yeah,
But I guess maybe
particularly not ones in more remote areas.
Not Hollywood cameras really up close.
Oh, no.
Yeah.
And, you know, we do get, like, it's like grainy webcam footage a lot of the time. But it's still cool, especially when they capture volcanic lightning, because volcanoes can create their own weather. So you have volcanic lightning and volcanic thunder, and, I mean...
Let's talk about that. So it's a localized weather system, or there's, like, actually, like, lightning coming out of a volcano?
It comes out of the clouds. It comes out of the ground and goes to the clouds, but it's charges that happen because of the eruption. So you'll see them in the eruption column. Like
so it's not atmospheric charge. It's
not.
actually like
it comes from the charges in the air and what the volcano is producing, and it's amazing. And you know, I'm not a volcano lightning specialist, so I can't go too in depth on it, but it is also like an emerging field of study.
Well, now when I teach my kid how to draw a volcano, there's going to be lightning coming out of it too.
Well, yeah, actually,
throw it all on there.
What's really cool is the USGS, their volcano hazards team, which they formed after St. Helens erupted, their logo is a cross-section of a volcano, but it's scientifically accurate. So it has like underground, you have what we call dikes and sills, which are like where lava flows kind of like sideways or cross-cuts up through older rock. And then it has, you know, pyroclastic flow coming down the sides. It has lava. It has the eruption column, and then there's volcanic lightning. And I'm like, they nailed it.
That's pretty cool.
It's so good.
That's nice. They got accurate scientific
on a cool
imagery
logo.
into a logo.
Yeah, I'm thinking about getting that as a tattoo, actually. So, because it's so cool, but without the words, you know. The motto for the volcano hazards team is Ne plus austae aut urbis ordem or something, but it means, it's Latin, but it means never again shall another city be destroyed. And that's what they try to work towards.
You think that's true? You think we're not, I mean, that's the obvious goal, but you think with uncertainty and everybody having a hard time coping with uncertainty?
Oh yeah, no, it will be destroyed. There will be other cities destroyed, I can guarantee that, because we keep building your volcanoes because they give us so much good stuff. I mean, good weather, good soil, like they're beautiful, so... And a lot of them are on islands that have been inhabited for millennia. So they're attractive places to live. I mean, the whole Ring of Fire, the whole Pacific, you know, the whole basically from Alaska all the way down North America, South America, and then cut over here to Oceania, and then all the way up to Russia. That's
So the
all.
whole globe.
Yeah, well, basically,
Everything.
if any of you are complete nerds, which I'm assuming a lot of you are, because look where we are, you may want to get this app called Volcanoes and Earthquakes. It's free. I don't get anything for telling you. It's just awesome, and you can download it, and it will actually, you can zoom in on the map to wherever you are, and it will track your location. So if you're flying and you turn the location on, you have Wi-Fi on still, you can see as you're flying. And I used it in Java in Indonesia, which is a long island east-west. And we just went by volcanoes, and I was like, oh, that's Sinabung. Oh, that's Merapi. Oh, that's, we were going past them. And we were going past one, and it erupted, and its status on this app was erupting. And I'm like, oh.
Whoa.
But yeah, that app will let you see where the tectonic plate boundaries are, and then you can see where they match up with volcanoes, and then it tells you when they're erupting, or they're like at a heightened alert level, or if they're currently just chilling, or if they're extinct. So it'll give you, based on color, and it gives you details on each one. You click in, and it basically connects to the Smithsonian Global Volcanism Program's database. So you get really good info about whatever volcano you want.
Okay, so I got a couple dumb questions, maybe. So first, if someone wanted to go see a volcano, because I mean we've got a lot of adventurers here.
A few.
Where would, like they're leaving from Los Angeles? Where would they go to get a good view of a volcano and see some action? So
you want to see action? Well, okay. For the tame local experience, if you're not able to travel out of the country at the moment, or you just don't want to, Lassen Peak has fumaroles, and it's got like active gases that come out, and you can actually see that. And Lassen it's not that far. I mean, it's northeast of Sacramento, so. You could drive there, and that one will show you some activity. It's not erupting, per se, but it's got some activity, and you're like, oh, it's a legit volcano. If you want to go somewhere and you want to guarantee seeing something cool like active lava, Kilauea is doing stuff now. It's a little harder to see than it used to be because it's collapsed. The caldera at the summit has collapsed quite a bit, so you can't have access the way you used to. But you can be like, I was there. And you can do overflights of it. They have helicopter overflights, which are really cool. And then you could go to Masaya in Nicaragua, which is a little closer, but super awesome. I mean, they have a parking lot. And then you just walk to the edge, and it's like lava lake. And it's actually like a double lava lake. It's
and
got
you can hear.
You can hear it if the wind is just right, because you're actually pretty far up above it.
Okay.
I was a lot closer when I did my camera installation work. But you can see it, and if it's a quiet day, you can hear some of it, and it's pretty amazing. But those are the closest ones. Also, Mount Etna, go visit it. Right now, it's putting on a show. Like it is, you get fire fountains there. They're actually lava fountains, but they're called fire fountains colloquially. But lava fountain is the correct term.
Where's Mount Etna again?
Sicily. So go to Sicily, get some great food, and because you can't go wrong there.
So when you go to a volcano, if we were, how stupid do they let you get? Like, can you just walk into it, or are there barriers like Nicaragua, for instance?
There's a fence. It's like a brick or rock wall.
Yeah.
I wouldn't go over it. Just saying. But in countries that are more developed, you tend to have more rules. So. They used to let people go out on the flow fields of Kilauea when it was erupting on that part of the volcano. It's not doing that now. And they tried to keep you in a certain area because there's risk of collapse. And you could always fall into a lava tube, which is basically a highway for lava to go down the volcano, but it's under the surface. Or the whole thing can collapse into the ocean. Remember, creation and destruction?
Yeah.
If you go to like Costa Rica, you can get a lot closer to some of the volcanoes like Arenal or Turrialba, and they don't tell you to stop as much. And in Guatemala, you get a real good up close and personal experience there, but you have to be careful because they don't give you much guidance. But if you go to Pacaya volcano in Guatemala, oh my gosh, there's lava flows that you can, go pretty close to, but just be careful and, don't wear nylon clothing. Don't wear any synthetic fabrics. Wear natural fabrics like leather shoes and cotton clothing is the best way to go because the other stuff melts when it gets really hot. So just on the off chance you're a little too close. And just remember that whenever you're near an erupting volcano, whether it's an oozy one or an explodey one, to use the very basic terms, you're in danger. I mean, it's a hazard zone. So there is a level of risk. No volcano is safe, ever. Not when they're actually active. So just remember that.
So you kind of mentioned there's basically two types of volcanoes then?
Well,
would you say the oozy one and the
it's
explodey one?
It's a little more complicated than that, and but those are like, it's about the kind of lava those are producing, because you can get there's cinder cones, and then there's stratovolcanoes or composite volcanoes like St. Helens. There's shield volcanoes like the ones in Hawaii. I think I have a picture of a shield one in there. It's a long, low mountain with a wheat field in front. It looks like wheat. It's not actually wheat.
So a shield volcano would be like
that one.
Yeah.
It's coming. There it is. That's Mauna Loa. And you see it looks like a warrior's shield turned on its side. And that's where they got the name from.
And that's because the lava is runny?
Yep. And it doesn't build up the layers, the explosive debris layers, the same way that you get on the stratovolcanoes, which comes from stratigraphy. So there's layer, 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 and then it's like Mount Fuji, or St. Helens.
So the ones that kids draw.
Yeah, the little pointy kid ones, and that probably most adults in this room would draw, given the chance. Someone says draw a volcano, that's what you're going to do, the inverted V.
Right.
Yep. Even I do it. It's easy.
So while we're on the topic of dumb questions, I don't know if that last question was that dumb actually, but movies, out of all the phenomenal volcano movies that are out there, which is the best one?
I actually am a Dante's Peak proponent compared to some of the others, because they consulted real live volcanologists and actually listened to them most of the time. Like the way they portray the scientists and the way they interact, and then the instrumentation that they use, that was actually really accurate. What wasn't accurate was the time frame. Like everything in that movie was super compressed to the matter of a couple days. And then also grandma getting into the lava, the acidic lake, and then dying, quickly. No.
Yeah.
No. And then of course the funny thing is it's supposed to be an explosive kind of erupting volcano. And yet suddenly you have this lava flow that's racing through the screen, and I'm like, it doesn't do that. But for the most part, that one's better. And then I like to tell everybody, well, yeah, of course Pierce Brosnan looks like every geologist. We are all just that attractive, especially the volcanologists,
Basically James Bond.
Oh, yeah, totally. Just with, exploding mountains instead of really cool Aston Martins.
Yeah. But yeah, what did he have? Some sort of Bronco or something in that movie?
Yeah,
that was my favorite movie, though. That's interesting that that's the most accurate.
And if anyone's worried, because you saw the movie Volcano with Tommy Lee Jones, the La Brea tar pits cannot, will not, and will never erupt. It's not going to happen. So yeah, no. and you cannot stop lava with a Jersey barricade, a concrete barricade, or a bus.
Really?
Yeah, really. And there was an instance, I will say, because of course you always get the person who goes, but wait, there was. So you can't spray fire hose water onto a lava flow and then stop it, with the exception of Iceland, because they are just next level in everything they do. And in Iceland, there's the Vestmannaeyjar is a little area it's a little island that's got, it's right below the main part of Iceland. And in the 70s, Vestmannaeyjar had an eruption, and the lava was coming towards the town's harbor, and it was going to close off the harbor, and then everybody there was screwed. So they were like, we have to stop this. So they went and got boats, and they pumped seawater in, and they just doused the lava flow, and they actually were able to change the flow direction. So you can't stop a lava flow with water, but they managed it because they're Iceland.
A lot of water. So basically what they did is they cooled one side and it kind of diverted it.
Yeah.
Yeah.
But it worked. It worked. It saved the harbor, and it's a cool story. I mean, but
That
it's
is a
Iceland.
cool story.
They're the most hardcore people, I tell you. I mean, they live on a volcano island that is literally rifting apart because it's two different tectonic plates. It's so cool.
Yeah.
Yeah.
They got some scientists there, huh?
Oh my God, yeah.
So,
the volcanology there is great.
I want to talk about your nonprofit too.
Okay.
Can you explain the nonprofit that you started?
Yeah, I actually co-founded it with my husband Carlos 8 years ago, and it's called Blueprint Earth. And I did it because I worked in industry as well. I worked in mining, actually coal mining and then hard rock mining in Australia, and consulted for companies all around the world. And I was like, look, I love the planet, I'm a total hippie tree hugger, but I also, I understand that we need to systematize the way we do conservation efforts, and we need to try to repair damaged environments, because unless we all want to give up our smartphones and our TVs, we're not getting rid of mining. We still need to do it. We just need to do it more responsibly and more sustainably. So I was like, okay, what if we can repair and restore damaged environments, whether they were human damage, like, a mining project, or deforestation, or, climate change is shifting some things and it's altering habitats. Can we take snapshots of environments and then create a blueprint for how they all hang together? So we're talking everything from microbes to the clouds and all the stuff in between, and basically figure out how it all is connected. And so our first environment is in the Mojave Desert. It's actually out near the town of Baker, between LA and Vegas. And we take college students. And I think there's a picture in there of us with our students kind of in our research area. And it says Blueprint Earth at the top, so should be, yes, the giveaway. So we do geology, biology, hydrology, and atmospheric research. And there are volcanoes in the area, but they haven't erupted in 10,000 years, so don't get too excited. But we get to teach the students a bit of all of those things. And what's amazing is the kind of participation we get, because we do it at no cost to the students. And because field research is pricey. I mean, if you guys know, expeditions are not cheap. And a lot of students from like lower income backgrounds, they don't have that opportunity. So we do everything through grants and individual donors. And I mean, we've had some corporate donations, but like, we basically are creating these environmental blueprints, and we want to go on to do each of the Earth's 7 major biomes. So, everything from the tundra to the grasslands to the ocean itself. And we're doing it in these small little areas, like a square kilometer, and saying, okay, how does the pocket mouse connect to, this atmospheric pattern that we're seeing? What does the pocket mouse eat? What does it drink? What preys on it? What does it prey on? And we make those connections, and we figure out what's invasive and what's not. And we have to include the invasives, because this is the world we've got.
Right.
So, yeah, so that's what we do, and it's cool.
And this is very local. This is the Mojave, right?
It
So
is.
how would people get involved? Because I'm sure lots of people, that watch this or at the club are into this kind of stuff.
Yeah,
and they like to get out into the Mojave Desert for some reason.
Yeah, we haven't done any expeditions since COVID hit, which made us cancel some last year, of course. But we're going to start again in the fall, and we typically do about 5 expeditions a year. They're 5 days, so they're not too long, and we do camp out there. So no beds, no toilets, no running water.
You do it in the summer or the winter?
We do it fall, winter, and spring. We don't bring people out in the summer because I don't want to kill any students. But if anybody wants to come along as a volunteer researcher, if you are not a student, which maybe some of you are, but if you are not, and you have some financial cushion, we just ask that if you want to come out with us, you donate at least $100, because that actually covers the cost for 2 students to participate with us. We do it very cheap because we are good at bootstrapping. It's a nonprofit, right? But when we get these, when we get the information from the environment and we build the blueprint, we want to test it. So the end goal is to actually create like a desert in a box for the case of the Mojave, but to kind of recreate it, because when you replicate something, that shows you understand how it works. And so we want to create a desert in a box, like in a giant, like imagine an IKEA, but instead of furniture from Sweden, you get a desert we can simulate the larger animals. Like we're not going to put a bighorn sheep in an IKEA, but we can put lizards and smaller creatures in there, and then let it cycle, see if it's actually working as an environment. And then that will allow us to someday assist with reforestation efforts, rehab for mining projects, natural resources projects, and even space exploration. Because if we get enough environmental data, we can optimize an environment for going to Mars, going to the moon. Like if we want to actually sustain life somewhere, we need to know the optimal way of doing that. And I mean, we can't just, phone in for a pizza, so we got to do it ourselves. And that means we need in-depth understanding of how all these different things connect.
That's a pretty cool idea, because I think most of the time we just kind of like, if we mine someplace, we kind of let it go back to nature, and nature. But if we could kickstart that and make it happen faster.
Let it go back to nature is a very generous description. In a lot of places, it's, throw some dirt in the hole and call it good.
It is amazing how fast nature does. I mean, I remember you were commenting on the TV show about like that moss on those rocks.
Oh my God,
these rocks are younger than you are, and they've got like all this moss grown on top
of them. It looks ancient, but it's not, and nature is, it's the best scientist. I mean, it's got the biggest natural lab you could ask for. And, it's up to us to inquire about what makes it tick. And that's what keeps me up at night, literally. It's like I don't sleep that much because I'm always like, what can we do to unravel this mystery that we live on, the whole planet? and let's go see all of it and experience as much as we can. I mean, and I just like volcanoes because they're a conduit to get people talking about it. And like, look, our planet's not static, it's not cold, it's not dead.
Yeah.
It is growing and changing and evolving, and we are too. And so is our understanding of it.
That's cool.
Yeah. And then, I mean, I guess the only other things that are like super relevant coming up, I did do this other Discovery show. Can I talk about it?
Sure.
Can I show them the little picture?
Yeah,
we have a graphic.
This is a new project, right?
Yeah, this is unexpected for me. It is Hunting Atlantis.
So I was going to ask, is the reason they brought you on this is like Atlantis got destroyed or slid off the Earth into the water from a volcano or something like that? That's why they wanted you?
The Atlantis myth / legend, however you want to view it, basically says that the city was destroyed in a day and a night. So they needed somebody, I mean, Stel Pavlo, he's my co-host on the show. Well, I'm his co-host. He's technically the host. Whatever, it's fine. But it's his baby, so I'm fine with that. But he wants to re-examine the legend because he has a different date than what has previously been suggested. Doesn't mean he thinks it's real, but he's like, if there is some truth to it, I mean, most stories that humans have some elements of truth. So there must have been a society that was accomplished and, you know, ancient that gave Plato the inspiration. So can we find evidence for that in a different era than anyone has looked before? And they said, we need somebody who can do, I mean, Stel's a writer and a historian. Like, he doesn't, you know, rappel into the world's 3rd largest sinkhole, which I did on the show. And I may have put a picture of that in there, which like I can show you guys, because the show premieres on the 21st. I think it's a Wednesday in a couple weeks. But yeah, it's basically, if there's a picture in there of me wearing black pants and like on a rappel thing going down into a giant hole, then it's there. Can't remember if I put it in or not.
And this is part of the show. Just go down that sinkhole, see if Atlantis is down there.
Well, yeah, we were trying to take dates. I did real science. I got my colleague at the University of New Hampshire, my friend Joe. I was like, hey, Joe, like, I need to take a date from the side of a sinkhole. It's huge. Can we do that? And he's like, yes, do it this way. And I'm like, perfect, that's what I thought. So I was scrounging for tools. That was one of the things that the executives didn't have a plan for Croatia. So I got to go, I mean, they had an idea, but then everything changed. And then they said, well, you need a disaster. And I said, let me do some research. Croatia's known for a lot of sinkholes by the coast. And there's, you know, the world's 3rd largest, which is taller from the bottom, which is underwater, to the top than the Empire State Building.
Wow.
So I rappelled into that and got my samples on rappel, which is, until you've tried to crack a kilogram of rock off the side of a cliff with like literally an abyss below you, you haven't lived.
That's pretty legit.
No, it was cool. And I'm not like an expert rappeller or anything. I do what I need to do to get the job done.
How was coming back up?
Kind of awesome. They didn't show that part though.
Did you have to climb back up, or did they just kind of
Part of the way.
back up?
And then some of the way, like, you could actually scramble up the rocks for the last bit.
Okay.
But we were still on, like, we had a fixed line that we had the Croatian Alpine Rescue Team there was our safety group. And they fixed that line so that when I was done, it would be easier to get back up.
Seems like this is a theme, you working with Hollywood, trying to, you know, they're trying to produce something, and then you're trying to get some science done at the same time.
Yeah, but I will say with the Atlantis show, I can't tell you whether or not we found it, but I can tell you we found some spectacular stuff that we have never, ever seen on TV before. Like, this is some new, amazing archaeological artifacts, and we worked with scientists and researchers at like New York University, at Cambridge. I mean, these are legit people. So we got to see some stuff that I'm really excited for people to actually see.
So that's the 21st. That's coming out.
21st, yes, first episode. It's 6 episodes.
All right.
Yeah, and then the only other thing is I have a book. I only brought 5 copies, but if anybody wants to buy a signed copy.
Look out there and tell they're already sold.
Yeah, the book is about my volcano work and then how I got started doing science on TV, which was not expected. But it's like, you know, it's called Misadventure. And I mean, I made it as a pun on purpose because, I mean, one of the chapters I'm in Peru and I literally fell in a sewer full of human feces and then had to go on an almost month-long expedition at over 16,000 feet elevation while my leg turned black from here to below my knee. And I was limping. It was great.
That's rough.
It was awesome. And we were like, you know, 15 kilometers from Machu Picchu the whole time. So it was amazing. But like, that's the kind of stuff that's in the book. And funny enough, because Patton Oswalt did the blurb that's on the front of the book jacket, because I know him, he blurbed it for me. And then I got a call, even before it was released, from the guy who produced Natural Born Killers and the Transformer movies.
Yeah.
And he's like, I want to make a movie where you're like hanging into volcanoes and like saving the world. And I'm like, well, that's not quite what the book's about, but maybe you should read it first and then tell me.
Everybody could use another volcano movie, right?
It would be way better. That's all I'm saying. Like, we can improve. I mean, I may not be Pierce Brosnan, but I can repel better than he can.
If you could get anybody to play you in that movie, who would it be besides you?
Oh, man. I don't know. I really don't know, because the worst part is Hollywood has this like interchangeable cast of redheads. And I'm like, look, unless they have a mohawk, which I do, I wear it all the way up for Explorers Club events. But most of the time it's just to keep the SoCal heat to a minimum. But yeah, I'm like, if they can actually rock a mohawk, they can get the job. But that's the big requirement. Yeah, and survive falling in a sewer full of feces, human feces.
Yeah.
But yeah, but I mean, yeah, if people more than 5 of you want a signed copy, I can get your info and get you a book, because I live in LA, so I'm assuming you all do too. But
well, at the end here, we normally do a little Q&A, so I'm
Yes.
sure lots of people in this audience have questions to ask.
If you
So,
haven't
Alec,
melted, it's a little warm.
It's not, I mean, for someone that spends their time on a volcano.
Yeah, but I'm thinking of the poor folks watching back there.
No, it is very warm in this room.
Yeah.
But all the talks have been from people who, Steve was complaining the other day, and I was like, didn't you just come from a jungle? He's like, I hated every second of it.
I mean, we love to hate it. It's the love-hate relationship.
Yeah. All right, so do we have any questions from the audience or from the chat? Right over here, Alec.
So what's the status?
Oh, let's wait to get that mic.
Podium.
Yep, podium mic.
There it goes. Okay. What's the status of the Mammoth Mountain nowadays?
So keeping a close eye on that one too. There is a CVO, California Volcano Observatory. Or actually, no, that's the Long Valley. Sorry, CVO is Cascades. Long Valley Observatory keeps an eye on Mammoth. And the last I heard, things were basically baseline. So, I mean, you get a few little earthquakes here and there. There's gas emissions. There's a lot of CO2 emissions in that area, which sometimes we associate with tree die-off. But right now, I mean, I wouldn't lose any sleep over it.
So the U.S. actually has observatories on most volcanoes,
Yes,
which is a good
because
thing.
thank gosh we have funding for at least some of it. We could always use more. Again, write your Congress people.
So theoretically, there's a scientist looking at all of our volcanoes being like, we're probably good.
Yeah, they actually have constant monitoring of seismic networks and inflation, deflation, tilt. You've got the gas monitoring. I mean, they do a lot. And when you have an eruption, like when Kilauea started going in 2008 at the summit, they had a 24-hour watch. So I was one of the people who was sitting there midnight to 4 a.m. like staring at the volcano going, what's going to happen? And looking at all the readouts. So when it's something that could threaten people or property, like a lot of it, they get people on it like 24/7.
Got one from the chat? You pointing up?
Oh,
From
is that the chat is up?
It's the chat. The cloud.
The cloud. All right. How does the chat ask a question?
The voice of God.
Oh, okay.
It's going to happen. Is the voice of God there? Hello.
God has forsaken us.
I can do the one from the audience. Anybody else from the audience have a question? Michael?
I'm going to go fix the voice of God while this question's going on. I'm going to
Okay.
step off stage for a second.
I don't know if it's true, but I believe most volcanoes are in the northern hemisphere. Do we know why?
There's actually a lot in the southern hemisphere, but a lot of them are undersea. So it is still very volcanically active. It's just we also don't have that many populated areas in the southern hemisphere, as we do in the northern hemisphere. So we just don't hear that much about the volcanoes in the south. So if you find that app, that Volcanoes and Earthquakes app, you can see, or if you just go onto the Smithsonian's Global Volcanism Program, they have some really good maps. There's actually a bunch in the southern hemisphere as well. We just don't hear about them because they're more isolated, usually. Obviously, New Zealand, notwithstanding. Yeah, they have a few. But yeah, of course, the whole coast of Chile, Peru, Ecuador, and Colombia, it's volcanoes. Like, as far as the eye can see. If you ever get a chance to fly along, like if you go from Lima, or like from Iquitos in the north part of Peru down towards the south, like to Cusco, it's just volcano, volcano, volcano. It's really amazing.
All right, next question. Is the chat ready?
Yes, sir.
There it is.
There it is. Hello, yes, this is God. My powers are back now. I'm back from lunch. Next question from the chat is, if the Adventurers Club were a sports book and the major volcanoes in the world were racehorses, who would you put your bet on to erupt next?
It can't be one that's already erupting, huh?
Nope, that's cheating.
Oh my God. Well,
That's
right
wording.
now, I will throw a fact at you just to, deflect from the, wow, that's really hard to predict. 45 to 50 volcanoes are erupting right now around the world, like as we speak. So having another one start erupting is like no big deal in volcano world. We are used to that. It's if you want to talk about like devastating ones, I mean, it's almost too much for any one person to know. So how I would make a bet on that is I would go to the Smithsonian's website for the Global Volcanism Program, and I would look at all the reports that have come in, because they update all the reports weekly. And I would just check the most recent reports and be like, this one seems bad. Like the eruption of Nyiragongo recently, we weren't hearing too much about it because their volcano monitoring agency is a bit under-resourced. So they didn't have the right sort of personnel and monitoring. They try really hard, but they don't have that much to work with. So that one, the broader volcanology community kind of went, I mean, it makes sense, but we weren't like staring at it with bated breath, But yeah, I mean, it's common. Every day, 45 to 50 volcanoes are erupting. So it's sort of a normal day in the office for us.
Sounds like a new betting website that we can put up there.
Volcanoslots.com.
Volcanobets.com.
No. Yeah.
Thank you. Really enjoyed your talk. What about global warming? What impact do you think the volcanoes have, all these 40-some volcanoes erupting around the world have on global warming compared to the human impact of global warming? If you can compare those two.
I love that question because, I said the number one is Yellowstone. The number two thing that I get to talk about is what are volcanoes doing about, what are they doing to the global climate system? Well, rest assured, volcanoes do, in fact, produce CO2. You probably guessed that. But they produce annually less than 1% of the CO2 that is emitted in total. So we're talking like all the human emissions dwarf volcanic emissions. And even if we have a very big eruption like Tambora, which was a huge one back in the day, a couple hundred years ago, Krakatoa, those kind of events, even a Yellowstone level event, that will actually cool the planet's temperature for a year or two. It has a global cooling effect because of all the particulate in the atmosphere actually provides an insulating effect. So we see volcanoes assisting a slight cool down temporarily. So when people look to volcanoes and point fingers at them, I'm like, no. It's minute in the grand scheme of the climate system. What we put into the greenhouse gases, I'm not a volcano, what volcanoes put out there.
So to kind of follow up on that, like you mentioned like Krakatoa and some very Yellowstone event. How does that compare to like a Mount St. Helens event? When Mount St. Helens went off, what kind of percentage did that put into the atmosphere?
Tiny.
So
we rate eruptions. It was basically like, we have ways of gauging earthquake size. Volcanologists said, we need something like that. And they came up with what we call the VEI, the Volcanic Explosivity Index. And it goes from 0, which is a Hawaiian-style eruption, a gentler eruption that doesn't produce very much lava, all the way to an 8. And that is like a catastrophic Yellowstone, a super volcano event. And I put that in air quotes because it's a term that has sort of recently come into being. It wasn't a technical term for a long time, but now it's much more accepted. But the St. Helens on that, it's a logarithmic scale. So it goes up by orders of magnitude every time. And it connects to how much material is produced during an eruption. And St. Helens was VEI 5. So then it's a huge step up to a VEI 6, an even bigger step to a 7, and a massive step up to an 8. So we're talking over 1,000 cubic kilometers of eruptive material for a VEI 8. And I mean, that's an insane amount of material.
And when's the last time a VEI 8 has occurred?
Oh my God. Not within any humans' lifetimes. We've had 7s happen when humanoid creatures were around, but I mean, like Toba, I mean, that's a big one. Yellowstone can produce that. Santorini wasn't quite that big in Greece. It was a bit smaller, 6 to 7-ish. But, when you think about things like even Crater Lake up in Oregon, I believe it was a 5 or maybe a 6. But where Crater Lake used to be a volcano, a pointy volcano, Mount Mazama. And then when it erupted, it completely obliterated the whole top part of the volcano. And of course, that is eruptive material that comes, it's ejected. So we count that. But even then, that's a good size eruption, but it's not, again, it's not even close to what the Earth can do.
And that's an eruption of that size isn't really putting that much CO2 into the atmosphere.
No, it's negligible. The effects of like a St. Helens are felt locally and regionally for a while, but not for a significant amount of time. The only reason you heard about Eyjafjallajökull when it was erupting a few years ago in Iceland is one, because nobody could say it, and two, because it shut down all that air travel. Because the particulate matter is actually pulverized rock fragments. So that will screw up your engine real fast. And you don't want to fly through that because you can't see it. It's not visible when you're a pilot. So that's why, but it was localized. It wasn't like, down in South America, they were like, oh no, the volcano in Iceland. It didn't affect them.
Interesting.
Yeah.
All right, next question.
Next question comes from the chat from Lauren Mayfield.
Hey.
Hi,
What's your
Lauren.
favorite volcano and least favorite volcano movie? I feel like we got a sense for the favorite. What's your least favorite? Can we go into that a little bit more?
Yes, it is Olympus Mons because it's on Mars and I can't visit. So there you go.
That's your least favorite volcano. What's your least favorite volcano movie?
Wow. I haven't even seen some of the worst ones. In fact,
there's some real bad ones
I
out
just
there.
heard
know that's
about
true.
one that I'm supposed to watch, and I can't even remember what it was called. I think it's a Japanese one that I'm
Yeah.
like, you need to watch. One of my movie friends said, you need to watch this. What was it? I haven't even seen that one, no. But I've heard about that one. This one's like brand new. I think it came out last year, but I haven't.
San Andreas is pretty low on the list, though.
Well, that's not even volcanoes. That's just.
There's lava, though, right?
Actually, the worst, and I'm sorry to say this because I know people worked on this movie, but The Core is the worst geology movie because The Core has crystals inside of the.
Yeah, that's where they take the ship down, right?
Yeah, you
Yeah,
don't know.
sure.
And then the new Godzilla versus Kong, they go into like this under Earth, and I'm like,
Lava lake.
no. So you can't. I can suspend my disbelief to a point, and I'm sure everybody does that with their profession. I'm sure the mathematicians with some of those movies about like Turing.
Some
or
guys
whatever.
out there trying to build a bicycle to go over the lava, so
Yes,
not that
yes.
far off.
Never underestimate people's ambition to do bad ideas.
All right, next question.
I worked on Godzilla vs. Kong.
Did you?
Godzilla versus Kong.
And I'll have you know, we had a room full of volcanologists that were advising us.
Did they
the
all
whole-
cry?
No, I'm just kidding. We didn't
Okay.
have any volcanologists.
Okay, I was like, I bet they all sobbed openly.
So there is no Godzilla?
I can neither confirm nor deny the existence of Godzilla.
So my question is, what are the possibility of a volcano, like say in Hawaii, causing with an earthquake or maybe exploding into the ocean and causing a tsunami effect?
So what you would see from the Hawaiian Islands, which has happened in the past because we've actually used sonar, side scan sonar and stuff to map out the ocean floor in those areas, you actually have flank collapse of the volcanoes. And when like the whole side of a volcano that's almost 14,000 feet high sloughs off into the ocean, that is what can generate a tsunami. And that's what we call edifice collapse. It's just basically a big chunk of the volcano just is like, nope, not doing it anymore for stress-related reasons. Not that kind of stress, the other kind. But yeah, that has happened. And we see that off the coast of Oahu, actually. And if you know the landscape of Oahu, it's eroding. It's basically a lot of erosion at work, but it's a lot older looking landscape than something like the Big Island, which is still actively forming. And Oahu did have big chunks that just into the ocean in the past, and you can see the debris fields when you look at the bathymetry of the area. So that would be the biggest threat for a tsunami from the Hawaiian Islands. Other volcanoes like there's the hypothesis that Mount Etna, parts of its edifice have collapsed in the past and generated tsunami that would have been felt all the way across the Mediterranean. So yeah, pretty bad day for whoever's on the other side. And that we had a small tsunami when Anak Krakatau had its eruption in 2019, December 2019. There was a small tsunami that hit the west end of Java, and it actually killed a bunch of people. I say a small tsunami, it was still like 4 or 5 feet of water. It was something like that, maybe even 8 feet. But it was a bad day for a lot of people. So that is a real risk because you have these collapses that can occur whenever something's built up and it's not at what we call the angle of repose, which is a term for when things have reached equilibrium. You add more material or things shift or magma moves around underground and something breaks. So it's a very dynamic environment.
Good question.
Yeah, I like that one.
Thanks so
Let's
much.
take a few more out here.
A couple more from the chat.
Oh.
Next question is from Raimundo Perez. If there was one important fact about volcanoes you could introduce to elementary school students for the first time, what would it be?
It would be that volcanoes are proof that the Earth is moving, living, changing, growing. I mean living, not in the traditional sense. It doesn't technically breathe, but we live on a planet that is dynamic, and we are really lucky for that. So we actually get to see it growing and changing and basically challenging us to understand it. So volcanoes are a super cool opportunity to have a real window into what makes our planet, and by extension, our universe, so special. And we're just a small part in that, and it's our job to do the best we can to understand what makes it tick. Oh my
Good
God, I
one.
love talking to kids. I mean,
And volcano lightning. I feel like that's really been left out on a lot of drawings.
I know. I'm like, think we need to name some dogs
All right,
like
Lance.
volcano lightning.
For about a year, I worked on a project that dealt with the fact the Earth actually manufactures its own water at the magma level. And you go, where did the water come from? There used to be this molten rock. And have you run into anything? In this case, it was called primary water that was coming up through, being pushed up into the crevices, and they were able to locate where the primary water was. Have you run into anything like that with your study of volcanoes and magma and all the earth pressures that you get into?
Well, magmas do actually contain what we call volatiles, and that can be gases and liquids, and water actually can be a big component. And if you have water present in the subsurface, near surface, or even slightly deeper, that affects the way that an eruption happens. So you can actually, like let's say you have a bunch of water and you have volcano erupting in the presence of this water, it can actually change the way the lava is extruded. So there's like a kind of lava that only forms under ice, for example. And then you also get, when you have the steam and you have magma in conjunction, a lot of times the water will flash to steam. So if you do have water in the melt somewhere, it will become steam. And I mentioned phreatic eruptions earlier. Those are steam driven. You also have phreatomagmatic eruptions where you've got magma involved as well as this steam. And you do see if there is water, like this happened on Etna a few years back, where you had lava coming down the mountain. There were a bunch of scientists and a film crew from the BBC. You can find this footage online if you look it up, like Etna, BBC, volcano disaster kind of thing. Nobody died, but what happened was the lava flow came into contact with some snow there on Etna, and it just was a super violent explosion that resulted, and it threw chunks of lava at the film crew, and actually one of the journalists got hit in the head, and it was pretty intense. And I worked with one of the scientists who was part of it, Boris Benki over there at INGV in Italy. And he was like, it can happen anytime because we've got some kind of water present in the system, whether it's snow, ice, or liquid water. It's a real hazard because those are very violent eruptive events. So, yeah. But the primary water itself, I haven't come across that. But then again, I do with the stuff once it's on the surface. Yeah. But I do know what you're talking about. I've heard about that. So.
All right, next question, please. Let's do a couple more here.
Okay.
One more from the chat, and then we'll do one more from the audience.
One from the chat. Okay. Well, I'm willing to defer this if there are more questions from the audience, but the final two questions from the chat are from me. Actually, this is from God.
Well, we can't turn that down.
And it's a request for you to describe these two pictures that are up on your screen in front of you. So it's this one and this one. But we'll start with this one.
Okay, that is something that a lot of people would mistakenly call blue lava. It's not lava, it is blue, and that's not a manipulated image in any way, shape, or form. That is a genuine image, no filters. That is at Kawah Ijen volcano in Indonesia. It's on the east end of the island of Java. Its name means the lonely one in Javanese, and it is home to the world's largest acid lake, and also it erupts native sulfur. So we're talking almost pure sulfur straight from the ground. That is molten sulfur combusting as it comes into contact with the atmosphere. And it burns electric blue. It is unreal how pretty it is. And it's a lot cooler than actual lava. So I did an episode for Science Channel's What on Earth, and we went there. and you can probably find that online. But I walk right up to that stuff, and it's only about, I want to say, it was like 800 or 900 degrees Fahrenheit, so like relatively cool compared to what I usually work with. And I took a bunch of it, a big flaming chunk of sulfur, and put it on the end of my rock hammer and was like, this is so pretty. And the camera crew's like, isn't that dangerous? And I'm like, no, not compared to the normal lava. I mean, it's all relative when you're me, but don't try this at home.
What does happen if you drop that on your foot?
I mean, you're in trouble, which is why I wear really thick Caterpillar work boots,
Yeah.
not steel-toed. You can never wear steel toes to work near flowing lava because your toes will cook, which I don't advise. So non-steel-toed leather boots. And then the other picture, do you want to, okay, yeah. So I ran for Congress while having a mohawk, and the picture with me in the blue suit is when I was running for office. The photographer who does the Explorers Club annual dinner portraits, he's a friend of mine, and he was like, I need to give you a picture with an American flag. I brought it just for you. So he took that picture, and it was like, hey, we need scientists to have a seat at the table. Whatever your party affiliation is, we need actual science informing policy. And on the right, that picture was of me the first time I wore a mohawk to the Explorers Club annual dinner. And I was standing behind the Fearless Girl statue there in Manhattan. And I just thought it was kind of cool because it was like, I just announced that I'm running for Congress. What have I gotten myself into? I am a scientist. But I was like, look, we need science to make policy. So here we go. And that's what that was. It was sort of my like leap into the abyss, the Indiana Jones, like, leap of faith. And I did it with a mohawk and in a suit and as a scientist with tattoos who loves volcanoes. And
That's pretty awesome.
yeah. And so it's just like, hey, we all can make a difference. It's just important to try. And however you feel called to try.
All right, one final question. One final question from the audience. Who's got the best one out there?
Now, is this on?
Yeah.
Now you said that the Yellowstone volcano is nothing to worry about. My question is, why is there such a big fuss around it, and why do people make such a big exaggeration if there is nothing to worry about? And why is there nothing to worry about?
The short answer is money, and it's because we all know if we learned nothing from the last couple of decades, it's that fear drives people's interest. It motivates people. And if I tell you, there's a volcano in your backyard that could kill us all, and it's erupted 3 times in the past 1.8 million years, and it's overdue, you're going to go, oh my God, how did I not know this? Oh my God, I better read that article. If I tell you, yeah, it's erupted 3 times, 1.8 million years ago, 1.2 million years ago, 640,000 years ago, it seems to erupt at intervals, but the odds of it erupting at any given moment when any of us are alive are tiny, because we're talking millions of years, hundreds of thousands of years. You're going to go, oh, okay. You're not going to click the article. You're not going to see their ads that are on their website, and it won't make them any money. So it's a sensationalism. I mean, again, we love certainty, and we love a sensation. We love a train wreck as humans. And so that is also the thing as scientists, is to show the cool, awesome parts of what we do, and then tell people when not to worry. Because they don't want to hear that. They want to hear, worry, worry, be terrified. And we're like, no, 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 don't be terrified. Like, we'll tell you when to worry. And then the challenge that comes from that is because we can't tell you exactly when the volcano will erupt, people go, oh, well, you don't know what you're talking about. But I'm like, no, you need to listen to us. You need to evacuate. So there's a delicate balance. And so that is why Yellowstone, it gets the hype because people think danger is sexy. And who doesn't think, we want to watch Shark Week. We want to see the storm chasers. Like, we're enthralled by the things we don't understand. And so I think more education, more opportunities to ask scientists questions or to learn what it is we really do, that's how we get people to go, yeah, you know what? We are all born as scientists. We come out of the womb and we are tasting, touching, smelling, like we're putting things in our mouth. The only way you learn is by like, ooh, that tastes gross. Or you touch the hot stove, ooh, better not do that again. And you're doing science. You are testing a hypothesis. And so we as humans are fundamentally scientists. It's just keeping that spirit of inquiry, looking for certainty amidst all the uncertainty. That is what connects us as humans. So if we push towards that and try to keep the fear in the background and the clickbait just where it belongs on the sidelines, that's how we're going to have a scientifically literate public, and we're going to keep exploring and keep having amazing adventures, and making things like what we all love to do in exploring our world possible. So, yeah.
Well, Jess, thank you for coming by and educating us. We thoroughly enjoyed this.
Thanks for having me. It was great. Thank you.
And for all those watching online, thanks for joining us at the Adventurers Club. Don't forget to stop by in person sometime, and we'll see you guys next week.